Hey gang, hope you're all loving life today. So in this video, we're going to be working on triangles again, this time focused on their areas. And we'll start with this. Areas are kind of fun. There's a lot of tricks involved with them. So I hope you like these ones. Triangle ABC is similar to triangle DEF. If side AB is 4, side DE is 6, and area of triangle ABC is 24, what is the area of triangle DEF? All right, so let's draw these out to imagine them. All right, so this will be triangle DEF or ABC, right? Great. And then what we want to do here is make two triangles and sort of think about how they're related to each other. Okay. So AB, they tell us, is 4. And now DEF, right, is going to be same type of thing. We'll make it a little bigger just to visualize it, but we don't have to be Da Vinci, right? We can just make a rough estimate to help us picture it better than trying to picture it in our heads. Especially the order of the letters helps, right? You want to make sure the order matches because that's how we know the corresponding parts and how we can determine a relationship, right? So here we have AB and we have DE. If they had given us AB, let's say, and EF, since those aren't corresponding because they're not in the same positions in the label of the name, then we wouldn't be able to do this. But since we have this, right? So the area for this one, right, is 24. So you might be tempted to find the height, right? Right. If you said 4 is the base, then we could draw a line and say, 12 is the height if we worked it up. But you don't even need to find that because you just need to know the relationship between this height and this height. And it's going to be the same as the relationship between the corresponding parts. So what is that relationship, right? So it is 6/4. So if we have this area, right, 24, you don't want to multiply that area just by 6/4 because that's only accounting for one dimension. But in every dimension, it's going to be 6/4 more. So it's going to be 24 times 6/4, and that accounts for one dimension. And since it's area, we have a base that's 6/4, and now we're going to have a height that's 6/4 more. So we're going to do, again, times 6/4. And now what I like to do in the multiplication, right, is cancel before I multiply it. So each 6/4 becomes 3/2, right? So 3/2, 3/2. And now the 2's cancel partly with the 24. So they become 1. And this one becomes 1. And 24 divided by 2 is 12. And divided by 2 again is 6. So we have 6 times 3, which is going to be, well, actually, let's do 3 times 3, because then we keep everything single digits, which will give us 9 times 6, right? Which is going to be 54. Okay. And the important thing is just to know the relationship stays the same across dimensions. So we just multiply by 6/4 twice. If you were doing volume, like I said, 6/4 3 times. All right, now let's go on to the next question. Okay. So on this one, right, what is the area in square feet of an equilateral triangle with a side length of 12? All right, so let's draw this one out too. Again, we don't need to make all the sides equal. We just have to remember that rule. And the important thing here is not just that the side lengths are equal, but the angles are equal, right? Equilateral triangles have all the angles be 60. And now we can draw a bisector from this down, right? That makes a 90-degree angle here. So we have a 30, 60, 90 triangle. We split this side, which was 12, into a 6 here. So that's across from 30. So then the height is going to be 6 times root 3. Okay. So now the base is 12. The height is 6 root 3. So we're going to multiply 1/2 12 times 6 root 3. Okay. And now with that, we can divide 12 and 2 to make that into a 6. 6 times 6 is 36, and the root 3 carries over as if it were, a variable. So we get 36 root 3. Okay, great. And that is B. Perfect. All right, so now we just have one more. The next one maybe is a little trickier, but I think we can do it. Okay, so here, what is the area of triangle ABC below, right? So we have ABC is the big triangle. We worked on this before. Remember that this dividing the 90-degree angle and making a 90-degree angle here makes the two little triangles proportional to each other and to the big triangle, right? So let's set up the relationship again. A, B, C is similar to A, right? Because that's the same angle. And then D, because that's the 90-degree angle, right? B was the 90-degree angle, and C, and then B. And also it's going to be similar to C. I like to start at the end here, right? C, and then the 90-degree angle here again is D. And then A. Oh, wait, sorry, not A. C, D, B. I was looking at the big triangle for some reason. Okay. No, why am I thinking A? See, we all make mistakes here. C, D, B. I don't know why I keep writing A. Maybe because I know you guys can all get A's on your tests. So now if you look at this triangle, right, we can do Pythagorean theorem to find DC. So let's do that. I'll write it out in here in the little white area. So it's 5 squared plus 12 squared, or just gave it away, plus B squared equals 13 squared, right? Because 13 is across from the 90-degree angle. It's the hypotenuse. So that gets us 25 plus B squared equals 169. So B squared equals 144. So B equals 12. Okay. Now, this 5, 12, 13 triangle, right? You can work it out like this, and that's great. But if you can remember that 5, 12, 13 is a proportion that comes up in right triangles, that makes your life a lot easier, and you can work faster and pay attention to the important parts. Okay. So now what we want to find, right, is AB. What is AB? So in this one, the short side, right, in BDC, right, we have BD is 5, and BD is the short side, just like AB will be. So we can set up a proportion there. So it'll be AB over, let's do 13 because that's the long side, the long height, equals BD over the long side. There is going to be 12, right? Okay. And now let's plug in for BD. So it's 5. So then AB times 12 equals 13 times 5, which equals 65, right? Perfect. And then we get AB equals 65 over 12. You can just leave it as a fraction for now. It didn't say to give it in decimals, so we can do it like this. And now we have 65 over 12 times 13 divided by 2 for the area. So let's do that here, right? Area equals 1/2 base, which we'll call 13, times 65 over 12. Sadly, there's no easy simplifying here. So let's do the math, right? 12 times 12. So area equals something over 24, right? So let's do 13 times 65 up here just to practice. So I like to do 65 on top. Then we have 13. And then here we go. 3 times 5 is 15. Good. And then we carry the 1. Then 3 times 6 is 18 plus 1 is 19. So we have 195. Great. Now we write a 0. The 1s is nice and easy. 5, 6. We get 5. 9 plus 5 is 14. So 4. Carry the 1. 1 plus 1 is 2. Plus 6 is 8. So it's going to be 845 over 24. Which we love. And that, my friends, is around 35. But we don't need to work that out. We can leave that as a fraction. Okay, so that is the work for today. And you just want to focus on thinking about similar triangles again, the rules of similarity, how everything's proportional, and then thinking about how to use that to find area, right? You want to remember 1/2 times base times height. That's one of the basic formulas that you really shouldn't have to look at on the test. And I'm sure you won't have to. Okay. And I'm looking forward to speaking with you all again soon. And don't be strangers. If you like this video, please like and subscribe, and feel free to leave comments or questions on this, or let me know if there's other topics you want to cover. Thanks.